Hello students, this video is designed to help with the Chapter 12 on Regression Inference. This is the second part of a two-part series on Chapter 12, Regression Inference. If you didn't see the first video, it might be a good idea for you to stop this one, watch the first one, and then come back for the thrilling conclusion. These notes are posted online. Hopefully you got a chance to take a look at them, and I'm going to give you a couple of minutes to try to fill those in. So pause the video, try to fill in what you can from the reading, and then come back and see if you got it right. All right. The first part talks about the fact that we rarely know the parameter sigma. That's the parameter for standard deviation. If we don't know that parameter, what do we use instead? Well, we learned this in a couple of chapters ago. We actually use S, the statistic S, which stands for the sample standard deviation. If we don't know the population standard deviation, we got to use the sample. The standard deviation of the sampling distribution, which you should know as the standard error, with a known sigma, with a known standard deviation, is this formula. And it's a little bit different than the previous formula. We talked about this a little bit in the previous video. You do have the standard deviation, the overall standard deviation up here, and you have the standard deviation of the x's down here. The long story short on that, if you have the standard deviation of the x's, that the larger that number is, then you have a better idea of the data set in general. So the smaller your standard deviation of the slope is going to be. If you replace the standard deviation with an estimate like S, the sample standard deviation, what do we have? In other words, it's saying rewrite this using the symbol S. And you can see that this is simply rewritten in that way. It's standard deviation, the standard error of the slope is equal to the sample standard deviation divided by the sample standard deviation of the x values times the square root of n minus 1. This is another way to write the standard error of the slope. It's included here because, well, one, it's in the textbook, and two, if it ever asks you on the multiple choice, what's another way to write the standard error of slope? Well, here it is. There are three different parameters in regression, and you should remember from the last video we talked about it, and especially from the last chapter, from chapter 3, we talked about the y-intercept of the population least squares regression line, that's alpha, and when we're looking at a sample, we use the small letter a. The slope of the population least squares regression line, we use beta, and of course, when we're doing a sample LSR line, we're using lowercase b, and then the standard deviation of the residuals for the population LSR line is sigma. When we talk about this standard deviation, most of the time we're going to be talking about the standard deviation of the residuals, the average residual, looking at the LSR line and also looking at the actual points along that line. Now there are two different aspects of regression inference that we could do. We can do a confidence interval. We can make up a confidence interval, which answers the question, in what interval does the true slope lie? And you should remember we did this, several months ago when we talked about confidence intervals, making an interval of numbers, and we're saying, well, we don't know where the parameter is, but we know that it lies within this interval. The confidence interval formula, the rough formula, is on the given formula sheet. It's on your AP test. And for this case, the statistic that we're going to be talking about is b, lowercase b. That's the sample slope. This t asterisk is the critical value. In this case, we're going to be using t because we don't know the standard deviation. We don't know sigma. And the degrees of freedom is n minus 2. And if you want to know why it's n minus 2, the textbook actually says it's beyond the scope of the book. So not to scare you, but there are things in statistics that you don't know yet. SE sub b, standard error of the slope. And if you ever want to do it on your calculator, this is how you do it. It's stat tests and then linreg t interval. For significance test, it's very similar, except in this case, you're not using a given t-value, a t-value with a given percentage. You're calculating a t-value and then seeing the area under the curve below or above that. But you're still using the slope of the sample. You're still using the standard error of the slope. In this case, however, we're using the null hypothesis for slope, which is always 0.
All right. Here it gives us instructions on how to do it in the calculator. Stat test, linreg t test. That's a little bit different than stat tests. Linreg t int. Obviously, this gives us an interval, and this does a test. All right, let's take a look at the hypotheses for significance tests. You remember that there should be a null hypothesis and an alternate hypothesis. The null hypothesis is what you're trying to disprove with a small enough p-value. And the alternate hypothesis is the thing that we could either accept if we reject the null hypothesis. Here we're trying to say that my null hypothesis is that the slope of the population LSR line is equal to 0, which means that there's no linear association between x and y in the population. If there's no linear association, then the line shouldn't be increasing or decreasing, shouldn't be doing anything. It should just be 0. There are 3 different scenarios that we could have as an alternate hypothesis. Well, here we're saying the linear relationship doesn't have a slope. Here we're saying the slope is going to be bigger than 0. It's a positive linear association. Here we're saying the slope is going to be less than 0 if there's a negative linear association. And here we're saying b is not equal to 0. Now, we very rarely use this one because this is saying there's some linear association between x and y in the population, but we're not prepared to make a judgment as to which one it is. Think about it. If we have a scatterplot in front of us and we are able to observe its direction, then why would we use this one? We could pretty much tell whether it's going to be a positive or negative association, so we very rarely use this one. As a matter of fact, I don't think that I've ever seen a situation in which we do regression inference in which we use a beta of not equal to 0. And also, don't get this confused. I know that beta is used in another context in statistics. It's used for type 2 error. Anytime you're using an H null and an HA, that beta is going to stand for the slope of the population LSR line. All right, moving on. The next 2 pages are practice problems. This one is for confidence interval practice. So pause the video, try this one out, and then come back to see if you got it right in a couple of minutes. All right, let's see how you did. You notice that they gave us a computer output here. This computer output is going to be pretty similar every time you get a question like this on the AP exam. They also gave us a scatter plot with an LSR line drawn. They gave us a residual plot, and they gave us what's called a residual histogram. We're going to talk about what that means, why they gave us that in a little while. The equation for the least squares regression line, we got the slope, which is 0.03013, and the y-intercept, which is 4.535 from your computer readout here. The coefficient, the constant coefficient, is known as the y-intercept. And then the coefficient of time in minutes, that's the coefficient of the x variable. That's right, the coefficient of the x variable is the slope. So that's what we got. Anytime you're writing an LSR line, you must define your variables. This sentence will probably not be there when you're answering this question on the AP, so please remember to define your variables. This x variable is time in minutes, so we could very easily state that here. And the y variable, I'm looking at the residual plot. The y variable is the tip in dollars, so just define it as that. It's going to be very straightforward. Interpreting the slope and y-intercept of the least squares regression line in context, this is very formulaic. I underline the things that are going to get replaced. For every blank, the blank blanks by blank. Well, for every extra minute the party stays in the restaurant, every incremental increase in x value, the y value, the tip amount, increases, we have this increasing line, by 0.03. And I rounded it to a real world scenario here because you're not gaining $0.03013 every time, you're gaining 3 cents. Interpret the values of s and r squared. Remember that s is the standard deviation of the residuals, so it tells us an average residual value, the typical difference between the actual tip and the predicted tip. Now, to be fair, it's not really the average residual because some of the residuals are going to be positive, these ones, and some of the residuals are going to be negative. But that's why we hedge our bets. We say it's the difference between the actual tip and the predicted tip. And we're not saying that the actual is going to be bigger than the predicted every time. It's not. But in general, it's going to be 1.78. That's the value of s, which is found, where are we at here? Found here. And then r squared is the coefficient of determination. It answers the question, what percent of the variation is explained by the LSR line? What percent of the variation is explained by using this x variable to predict the y variable? So that might be another way to interpret it. And of course, that's here, 13.2%. SE is the standard deviation of the sampling distribution of the slope. So it's pretty straightforward. And it's different than this S. Keep in mind that this S is the standard deviation of the residuals. Standard error is the standard deviation of the sampling distribution of the slope. If you remember way back at the beginning of this note session, I gave you a sort of sampling distribution of the slopes, and the middle of the sampling distribution of that slopes, that's mu sub b. That's going to be equal to the parameter, the beta. But the standard deviation of this particular distribution is the standard error. All right, flip back here. Here, if you want to pause the video and check it out, this is our state plan do conclude. I have no commentary for this except to say that the confidence interval is calculated the same exact way. It's the statistic plus or minus the critical value. This is either going to be z or t, or in some cases chi, but most of the time it's z or t. And then the standard error of the slope. So pause the video, check this out, see if you got it right, and then move on to the next page. Here's a significance test practice. It's a very similar kind of question. Here's a situation. We're not given a residuals histogram, but we're given most of the other stuff. So pause the video, try this out, and then see if you got it right. All right, and you'll notice that I copied and pasted the formula from the previous page. This is the formula that we're going to be using to do our significance test. We're going to find this t-value, then find the area under the curve, and compare that to your alpha. And they didn't give us an alpha here, but of course, significance tests, when you don't get an alpha, you're going to use alpha equals 0.05. It appears to be a negative association. It asks for the association. If it asks us to describe the scatter plot, we would need 4 different things. We'd need we'd need the direction, we need the form, we need the strength, and of course we need any outliers, but it doesn't ask us to do that, just the association. And it appears to be a negative association. That slope looks like it's negative. And you're going to hammer it home by talking about contextualizing it. The higher the row, like as the row gets higher, the lower the test score. You can see that that test score is going down. Again, we're defining our variables. Once we make our least squares regression line, the coefficient that is constant, that's going to be your y-intercept. The row coefficient is also known as the x coefficient, which should make sense to you that that is the slope. Let's see. For letter C, the value of the correlation. Well, correlation is another way that they use to say correlation coefficient, which is r. All they give us is r squared, but pretty easy to work that into r. We just take the square root. So that's negative 0.2168. Now, I know what you're thinking. You put square root of 0.047 in your calculator, you press enter, you got 0.2168. Well, that's not negative. Why is it negative? It's because of the association. We're given a line that's going downwards. So you know that anytime you get a squared value, it's going to be positive. So you have to interpret, if I'm calculating the r value, I need to figure out whether that r value is going to be positive or negative. In the previous example, this would be a positive r value. So if I took r squared and I square rooted it, whatever number I got, I would have to make that positive. In this case, whatever r value I get, I got to make it negative. The next part asks us to calculate and interpret the residual. It was easy for us to calculate the predicted value. That's from that LSR line that we made before. And remember that the residual is going to be equal to the actual minus the predicted. So that's an easy way to calculate that. Actual minus predicted AP. That's a good way to remember that. AP, because you're an AP stat. Interpreting the slope of the least squares regression line, remember it's very formulaic. For every blank, this first blank is the x values. The next blank is the y values. Either increases or decreases based on your line. And then by 1.171 points, that's by the coefficient of the x value. All right, interpreting the standard deviation of the residuals, 10.0673, that was in your readout. That's here. That is a typical score difference between the predicted score and the actual score. For interpreting the value of r squared, remember that r squared is a coefficient of determination. That's how much variability is accounted for by the LSR line. All of the other variables that the teacher controlled are the test, the subject, the classroom, the teacher. It reduces variation in results due to other factors. We're trying to figure out the effect of row on score, so we're trying to cut out all the other variation. Here is my state plan do conclude. One thing I want to point out, the residuals are distributed with no skew or outliers. I made this histogram myself by looking at the approximate residuals. I calculated each of these approximate residuals by hand, and then I made them into a histogram. You may have to do this on the AP exam just to show that you did your due diligence. All right, that is the video on Chapter 12 for Regression Inference. This was the second part of a 2-part video series. Good luck studying.